Well, hi, good morning, and thanks so much for joining me in my shop here. It's August 9th, day 2 on this Rogers Majestic tube radio. Yesterday I discovered a burned, or at least severely overheated coil in the radio, and that is the issue that we really have to focus on right off the bat. We have to resolve that before going any further with this radio. So the best thing we can do is take a little closer look at it, and we'll look on the schematic and identify what part it is. It should be pretty easy to do. Then we'll start thinking about what to do about it. So it's right here. So let's take another close look at it with the close-up camera. The other camera, here it is. So I was commenting on the shape of the coil. You know, I got fooled and thought it was a rubber band. You can see how fine the wires are in it. You could guess there are hundreds of turns of very fine wire. And I certainly recognize a woven pattern in it there. A little hard to perceive, but that has to do with what I was saying yesterday about trying to get these wires to not be quite so parallel in the coil. And this can give it, I believe, if I understand it right, a lower capacitance, and there's obviously some kind of advantage to doing that. Can't say for sure, so I'm just looking at the wires. So it could be these wires which are pulled out have kind of come free from the main bundle and have been kind of swept out from underneath for me foolishly moving it around yesterday. I feel like such an idiot now, popping it around this way, that way. It looks like there's a wire coming across from the lower coil. Or not. I'm not sure what I'm seeing there. Yeah. So recreating a coil like this, yeah, I can't do this. This is done in a factory with a machine setup to wind this coil. If it were just a straightforward one like the rest of it, I could rewind something like that. Look, there's even another, there's actually a coil here, and then this one up here. Ooh, don't touch it, man, don't touch it. Okay, in terms of where it is in the radio, well, it's the front end. It looks like an antenna coil to me. So we're going to take a look at the schematic and figure out what it is. Well, it's not going to be difficult to figure out which coil it is because they have coil diagrams on the schematic down here. And right away, there's only one coil with a larger winding on it here. Broadcast antenna coil. You got a wire here, a wire here, and a wire here. And you can see between this lower coil and the main one, there is a wire traveling there. Can't quite figure out exactly where these leads are going, 1, 2, and 3 from this, but we'll look in the schematic in a minute. Let's just look at the other coils. They're showing it. Shortwave, and so this is the antenna coil, broadcast antenna coil, shortwave antenna coil. Then we have the oscillator coils here. Okay, well there's no doubt it's T2. So let's go up here and we'll find T2. T2's right here. How the heck do you burn this out? Really? How do you burn this out? So first of all, which is it? Is it this or is it this? And they only show 2 coils. They show 2 coils. So one has a single lead Oh, there's the numbering. Number 1. Number 1. So number 1 wire must pass through this coil. Well, then it's got to just continue. So this coil is a complex made up of, oh geez, I'm not sure. Okay, number 3 here. So 3 is grounded. So we have 2 to 3 is passing through this part, the secondary side of this, if we can think of it that way. And we can think of it that way. 2 to 3. Well, oh, someone's at my door. Okay, so it certainly looks like the coil that is burned is this one, is the primary coil, and it's connected basically straight to the antenna, which in this radio is a bundle of wire sticking out the back. Well, that's what we think is the antenna lead, probably is. You can see this is the band switch here, and when you switch it from, I'm going to assume all wave band switches are shown in broadcast band position. So when you switch this switch, this arm moves up to post number 2 and there's nothing there, and this arm moves to post number 3 or terminal number 3. So basically you're swinging the antenna connection between these two terminals. So in the AM mode, the way it's shown now, the antenna signal is fed down through this transformer and this capacitor. And then this is the big tuning capacitor here. This is a trimmer capacitor to compensate for variations in the coil here when they manufacture the radio. So AM comes down here and shortwave comes up here. Look, they've drawn the coil smaller. And the frequency is much higher in shortwave, so you don't need as much coil to get the actions you need out of it. So what about this coil? Is it all burned up? And I'm just looking now again at it, and I can't even identify it for sure, but nothing else is burned up. Just the one coil. Just this piece here is the only piece that burned up. So to burn it, it has to be a heavy current going through it for a period of time. Could be extremely short, very heavy current, and that might suggest lightning struck this antenna and blasted this coil to pieces. I can't say I've seen that kind of damage. I couldn't recognize it if I saw it. Oh, I am being called away here once again. Okay, let's see if I can remember what I was just saying. So I was examining the switch here and noting that on one band this coil is actively connected to the antenna, and on the other band this coil is actively connected. Didn't see any damage anywhere but here. So whatever happened. Well, I don't know how to finish that sentence. So it's discussing lightning striking the antenna. You don't need the lightning to strike the antenna. You need the lightning to strike somewhere nearby. And if your antenna is long enough, you could develop a potential on the antenna relative to the earth. And it could be enough to do some damage. But I don't think it would like set a fire, right? I think you'd really need almost a direct hit. And it seems to me there would be a blasting thing happening in this radio. It would be blasted. It looks, to me, when I look at it, it looks like a long-term roasting occurred. How could that happen? Since the only current that can flow in this coil is current flowing out the antenna. How could that happen? And the only way that could happen, the only way I can think of right now, is the antenna got connected to something. Now this is a, let's look at the power supply just to see how they handle the grounding of the power supply here. So here's the plug coming in, the two wires, and they go straight to the primary here and nothing else. There's no capacitors shown here, anyway, no capacitors, just the on-off switch. So assuming this is all intact and there isn't a short inside the power transformer, which is possible too, then the chassis of this radio is isolated from the ground, the power system ground, the green wire ground, third prong, whatever you want to call it, the wide spade. Yeah. So the idea that power current flowed through here from the antenna. So for instance, maybe the chassis was made live, and then maybe the antenna was grounded, and so you'd have a reverse, not a reverse flow, but reverse power flow. Or maybe the opposite happened. Maybe the antenna got shoved in an outlet. Now who the heck is going to do that? I can't explain how this got burned. Let's try another one. What if a short circuit occurred in the coil? Physically, that's not particularly possible. Short circuit between these two coils. Physically, not realistically possible. They're not touching each other. So that can't happen. Really, yeah, I don't know. Maybe I'm looking at lightning damage and I just don't realize what I'm seeing. A blast of lightning. Well, okay. Regardless of how it got into the condition it's in, it is in the condition it's in. We got to figure out what to do about it. So, one thing I should do is test it for continuity. It's possible, regardless of what it looks like and the fact that I've bumped it around, it probably moves around when you're moving the radio around, it could still be in operating shape. So we need to find that out. So what I can do is I can put my ohm meter on the antenna lead and the other ohm meter just onto the chassis. I'm sure all these mean chassis here. Let me just take a peek at the radio and see if there aren't. Sometimes that means chassis, sometimes it means a wire running through the radio. No, lots of stuff soldered to the chassis in there. So, okay. So I just got to read resistance between here and here. And what would I expect? Coil like this with very fine wire, 10 ohms, 50 ohms, some amount of resistance here. Certainly not thousands. I wouldn't think thousands. I better not say certainly. Okay, that's what we'll do. So we'll just read from the antenna wire to ground and see what happens. And then I can flip the switch here and I can compare this coil and its effect to this coil. Okay, that's good. I like that idea. Okay, so this is a pretty critical test for this radio. Okay, man, this is gonna tell a lot. That's the antenna line. There's ground. Oh, son of a gun if it isn't continuous. Wow. Okay, so actually that's unexpected. Okay, what I need to do now, I think, okay, on the assumption from this test that this coil is actually still good, still functioning, is I gotta freeze it there. I could do it with a dab of glue. I could do it with some tape. It wouldn't take much. A little tiny dab of glue should hold that coil in place. Yeah, what I'm thinking about is how else can I test this coil out without actually operating the radio? To think about that one for a bit. Okay, well, I've just returned from a magical mystery tour with my computer. And I won't go into the details, but let's just say suddenly it was okay again. Well, okay, so I've tested this coil and I found continuity through it. But in thinking about it some more, it could be that the coil is shorted after being heated up the way it was. It could just be, it could be shorted out in there. So that way I would get a reading. I would get the low reading on the ohm meter, but in fact not the whole coil's there. And this is really driving me nuts because what happened here? So, I have to think about this because I want to turn the radio on. Well, I certainly can't turn it on with this schmozzle here. That's another headache I'm going to have to deal with. Wow. Headache is right. Now I'm thinking about this problem. Well, it's just a little overwhelming here. You know, replacing capacitors is the least of the issues with this radio. I got to think about this. The reason I would like to operate the radio as soon as possible is because I'm much more comfortable working on a radio that's working to some degree. Doesn't have to be working properly. Just maybe, you know, a good level would be you touch the antenna and something comes out of the speaker when you do that. Then, as I'm working along and I'm making changes, I can check back on the operation of the radio. And if it's gone downhill, I can consider whether I've just made a mistake or not. If, in fact, the radio's, if I don't have the radio in some kind of operating condition before really getting on to repairing it, I run the risk of making a series of errors. So I could go in and do what's called shotgun the capacitors, just change them all. Don't turn anything on, just change all these capacitors and then turn it on. Well, in the course of doing that, if I've made mistakes or introduced, you know, problems in the radio, which is possible, it's quite possible, goodness knows if I'm ever going to be able to sort it out. You know, very bad error to make with a radio is to connect a part in the wrong place, especially like a capacitor. And in the course of replacing it, instead of connecting it where it should be, it might move one lead over one terminal by accident. Sometimes that allows the radio to operate, but it operates weirdly or very poorly. Finding that problem is really, really tough. So you don't want to make mistakes, and if you do make a mistake, you want to catch it right away so you can correct it before you end up with a plethora of errors. Okay, I'm going to stop and rest here. I think the next thing I'll go after is the power cord, because obviously that's standing in the way too. And we'll have to figure out how to bite into this thing and expose some wire and bring this wire might be okay. Just shorten up the wire a bit. Must think about that. Well, a whole day has passed, and it's the next day now. It's August 10th. Oh my gosh, August 10th. And we're going to go after that thing. Now, this is a bit of a problem here. Before I start hacking, chewing, crushing, and burning, melting on that thing, let's take a close look at it. So, original power cord came in just like this one. The original power cord is still here, and it's totally shot. The insulation is shot on. I mean, this is definitely shorting out here. This is a horrifying thing, actually. This is going to be original. Now, the guy who put this cord on did not want to break into this, so he just used the tail end of the old wire. Something I've done in the past too. So two of these wires go right into the transformer. It looks like an extensive amount of wire, and they just kind of looped it around here. Well, they probably had it pulled out, made this connection, original connection, and then kind of folded up, looped it up to take up the excess. Why they didn't cut it back, I'm not sure, but maybe just the same way I'm anxious about cutting back leads to a transformer, maybe they were too in the factory. They just refused to do it. I mean, at that time these wires would be quite flexible. The problem with that arrangement, of course, is this thing is kind of floating here. It's really not. It would really be much better to have the leads come out of the transformer, go to a terminal strip, and then from the terminal strip go to the power cord. Now these wires have to get to the on-off switch. Where is the on-off switch? Not here, is it? Yeah, it is. This looks like a replaced part, but I'm not exactly sure yet. But it certainly has all the hallmarks of a replaced part. You can even see how somebody, when they hacked this shorter, because this would have come longer, and you cut it to the length you need. When they hacked it shorter, they didn't hack it even square. See, hacked on
angle. I'm pretty sure this was replaced, and that would replace the on-off switch. Listen to it. Hear the double click? Not a particularly good sign. So two of these, so this has got to be the primary going to the transformer. So we have the two power wires coming in, going to the transformer, but one of them peeled off to the switch and back. These wires going to the back of the switch are actually quite flexible. Tape off. So just crush it and it'll shatter. Pick at it. Tell what I'm cutting into. That's the problem here. Fair bit of flexibility in these wires. To cut into these two, I could leave the third one. It's going out to the switch alone. So you just cut this right off. Cut this right off. Oh, this is very short. This is the one to worry about here. Flexibility here, but nothing here. Through the middle of it. Go through the end of it here. So get this one out of here too. Okay. This is done again with friction tape, or what in Canada we call hockey tape. And this stuff is amazing. As horrible as it is, it seems to be much better than the modern electrical tape. Modern, yeah. Yeah, tape improved since 1937. There's a lot of tape on here. This wire is easier because it's so flexible. Here we are. Just strip back this wire. Don't really have to strip strip this one back. It's got an exposed area already. This one. Well, we'll try using the tool. So, I mean, how many times can I try stripping it back unsuccessfully? Not many before it's way back up in here. They did cut the wires short. They, you know what they didn't cut, I think, must be the switch wires coming from the switch in here. I could cut those back, or cut one back. Why would I do that? What would be the advantage? No advantage. Okay, there we go. So this tool, it detects the size of the wire by how far the orange clamps come in on the wire. So the farther they come, the farther the cutters will eventually go on here. It's a pretty thick wire. It's very brittle, so this might work quite well actually. We'll see what happens here. So sometimes I have to squeeze them a little bit. Beautiful. There's wire there. Not a lot. Let's take a little more off. Beautiful. Okay, we jumped that hurdle nicely. Now, should we put a new cord on or just use the same cord? The plug can turn relative to the cable. That's not particularly good. We don't know what's going on inside here. You can't re-enter this. I don't know how they make this. Made it in a factory. I think we can do a better cord. I should do this permanently. Okay, gotta find another piece of wire, I think. Okay, picked a new cord here. Got it fed through. Got a little strain relief knot in it. I'm using an unpolarized plug. That makes sense with this radio. The power goes straight into the primary of the transformer, only passing through the switch out here. It doesn't go anywhere else in the radio directly. So there is no polarity issue at all. The polarity being really which wire, which one of these wires is the neutral and which one is not. It doesn't really matter. As is the case with most of this old equipment. So, of course, when this was made, the polarized plug scheme hadn't been introduced yet. I seem to remember people saying, "Oh, it'll take forever. You have to change the outlets, got to change all the plugs." But after many, many, many years, shrink sleeves here. Okay, I'm going to carry on here, make these connections, and then I'm going to scratch my head and wonder, should I turn this radio on? Okay, I have those connections soldered up. This is the shrink sleeve. I'm going to slide over it. There we go. Okay, the other ones. Wire sticking out there. Okay, there we go.
This is one of the more exciting parts of the video.
Okay, just have to shrink this down enough so it won't slide around. We don't have to shrink it right down tight. In fact, that can be a disadvantage. I just don't want it to move around. That's plenty good. That last little bit you heard where the blower increases speed, that's a cool down for my hot air blower. In case you're wondering what's going on. Okay, now I'm going to turn this guy on. And we're going to turn this radio on. I say we because I plan to share the blame with you for what might happen. Well, we're going to turn it on. We're going to have it up this way so we can see what's going on here. In fact, I have a thermal viewer. I can keep an eye on this thing and we can detect its temperature rise. I can use this device here to slowly increase the amount of power going into the radio. But here's the thing. Based on my examination of the schematic and my understanding of what this part is, which I'm pretty sure is correct. Incidentally, it's glued in place now. Oh, I hope that was a smart move. Yeah, the only way I can see of how this could have gotten burned, there's really only like three ways. One is lightning strike on the antenna, or a voltage generated on the antenna because of a local lightning strike. I just don't think this is, I don't think it would look like that. I just think it would be blown apart. This looks roasted to me. This looks like a slow heating event over a long period of time, which is kind of mysterious too. So the next possibility is the antenna wire, which would be connected here, got, one of two things happened. Either it got energized at 120 volts. It's a little hard to see how that would happen. How would that happen? Somebody go stick it in an outlet? I mean, how's that going to happen? Or it got grounded. And the real problem with this radio is the chassis has become hot. Now, how could the chassis get hot if these wires don't go anywhere? The power wires don't go anywhere. And by hot, I mean the chassis is essentially plugged in the wall. It's right on one of the outlet wires, if you like. It's not supposed to be that way. The outlet wires are contained here, the switch, and the transformer primary, they don't go anywhere. So you should not be able to find 120 volts anywhere in this radio. Poke around all you like and never find it. But what if a short has occurred, either in the switch out here, which I can't see, it's too dirty. Maybe the terminal has touched the frame here. Maybe. Just a maybe. And or the transformer has a short inside it. Do you see the compound that leaked out here? Something made that transformer really hot. There, I just broke a piece of it off. Made it really hot, and this stuff just breaks away because there's a short in the main transformer. It could be a shorted winding in there. It could be a short to the frame. The short to the chassis could bring the chassis up to 120 volts. How does that burn that coil out? Because if you were to ground this, I think you could get a reverse flow of power from the ground right through this primary wire. Now this would be pretty exciting too. That'd be 120 volts pushing through this wire. I think it would look like that or even worse. So maybe that's what happened. The problem here is there's no easy explanation for how this happened. So that means I have no idea of what's going to happen. I don't even have a guess. So I have to be super cautious here. Okay, the first step in being cautious is to go and drink some coffee. Okay, let's see how this is going to work now. This is my thermal viewer here, and I've got it looking at the coil. To prove that, I'm going to put my finger where the coil is, and we'll see what we see on the thermal viewer. And there's my very cool looking, looks like my finger's being x-rayed, but they're dead center, pretty well, just a little bit low at the center. So what will happen now is if any temperature is around 25 or 30, we should see it a little bit red in here. And so for just my finger, can you see there's a little bit of red in there? I don't think my finger's 30, but it's warmer. So it should be pretty obvious when the little coil starts heating up. That's a little coil there, right there. Okay, next step is to turn this down. So this is set to output voltage right now. Now I have a complicated system here, stupidly complicated. This is an isolation transformer. I have another isolation transformer behind this. This is plugged into an isolation transformer. Or is it the other way around? It could be the other way around. The isolation transformer follows this. I can't remember now. So it's not just this guy all alone. And then I have the dim bulb system that I can put the energy that's going to the radio through these bulbs, which is what I normally do. I normally don't use this guy. But in this case, I think I'd be wise to use it. So we're going to set it low. Voltage here is 0 to 150, so we're down around 30 volts. That's awfully low. At 30 volts, the radio will have trouble heating up the filaments or the cathodes enough for the tubes to conduct. There won't be much B plus anyway. So that whole side of the radio will probably not really have any current flowing in it, have any significance. And I'm pretty convinced that if we start here, this thing won't overheat. I don't know. I don't know what the problem is, right? We don't know what we're dealing with. Maybe I should start right at 0. Yeah, why don't we start right at 0? Okay, plug this in. So this is going into my bench outlet. Okay, so this is just a device you can buy for $20, $30, $40. You plug in an outlet, you plug your item in it, and then you can read voltage, power, and all kinds of stuff. It's very interesting. It's a great device. It's just plugged into an ordinary extension cord. This extension cord is going back through the control panel, through this, through the isolation transformer, and then out to the power. It has a third prong on it. The third prong is just sticking out here. It's not going anywhere. This is just a 2-prong extension cord. There's no grounding. So this is one of the ways I maintain my own safety in here. But the fact is, in my shop, I've case grounded all the equipment. So all the equipment you see, all the metal boxes around the equipment, they're all tied together with a wire and tied to ground. So this is what I have resolved to do in my shop. And I have to tell you that the key thing to being safe, or as safe as you can be, never fully safe in a situation like this, is to be aware. Grab your voltmeter and make yourself aware of things. And don't go on any assumptions. And for crying out loud, if what you've got in your head is, I grounded it so it must be safe, you got some learning to do. You're not going to maintain your safety with ideas like that in your head. So, okay, so I won't go into it in any more detail. I'm not trying to instruct people on how to be safe in the shop. I'm simply telling you what I do, and I'm not giving you all the details even. So don't mimic me. That's what I would say. Okay, I think we're ready now to start up. We'll turn there's no power. We'll turn the switch on. Oh my gosh, this isn't the on-off switch. This one is. Okay, the switch is on. We'll turn the volume up a little bit. Being very hopeful. There's no antenna connected. It's just hanging here. This other wire, which I assume is a ground wire, don't know what it is yet. Okay, Mr. Coil, are you going to overheat? We're going to find out. I'm also going to put the power through these light bulbs too, on account of. Okay, we're going to fire this on. Now, what could happen here? Well, I got like 0 volts, so nothing really can happen here. This guy, he even needs like 50, 60 volts to work. So probably as I bring the voltage up, this thing will get locked up. Its little computer is going to go and get locked up. Okay, well, so far nothing's happening at all. That's to be expected. Okay, so we're going to start putting some voltage on it now. I got all kinds of voltmeters over here too that you can watch for fun and excitement. We got this one, we got this one, we got this one. So this one's showing the line voltage coming in into my shop. That's just a plugged in an outlet meter, and It reads a little high. It reads 121. It's not 121. It's 117 or something like that, I imagine. This one will read the output from here. This one will read the voltage here. And of course this thing will too if we get enough voltage for it to operate. This one's scale is not 0. It doesn't start at 0. It starts at 100 volts. That's 100 volts sitting here. So until 100 volts is presented, this meter doesn't even move. And then it can go up to 140. So this may not even move, because I may never get this high enough, because this is going to start smoking. That's kind of where we're going. Okay, we're still sitting here at 0. Nothing has happened. Switches are correct. Okay, let's burn that coil. Here we go. Try and keep my arm away from things. 30 volts. That's 30 volts. Give it a little bit of time. My device here reports 3 temperatures. In the center of the screen you can see a little plus sign. That plus sign temperature is shown down here in the big print, 23, 24. Well, that's kind of the ambient temperature in here. If I stick my finger here and raise it up to the plus area, you'll see that number go up. 30, 31 degrees. There's 2 more numbers you can't see. They're too small here. One is the highest temperature on the screen and the other is the lowest temperature on the screen. And you may see something hopping around up here in the corner. So what it's doing is every so often, very small so often, maybe 10 times a second or something like that, it checks for the highest and lowest temperature, places a marker on that spot, the pixel that's the highest or lowest temperature, and then reports it down here. So that's very, very helpful too. So I can see the numbers down here. You can't from where you are. Well, nothing has happened. So we're going to go a little further. I see my guy here is kind of locked up on all 8s. So we may have to... Let's go up to 50 volts. 50 volts. So obviously if it's a bolt of lightning, nothing's going to happen here, because we need a bolt of lightning to repeat the event. If the antenna was grounded and the chassis is live, we would even have some trouble figuring that out, but I think I can take a shot at that. Is the chassis live? Yeah, I can do that. Well, it's a funny situation. The chassis could have energy on it, but because I'm using an isolation transformer, it's not that easy to measure it and find out that it's there. Absolutely no heat showing up whatsoever. So we're going to go up a little higher. Now we're going to get into the range where the radio may actually start doing stuff. Tubes may start heating up. Just checking to make sure, yeah, everything's plugged in. This guy's looking for some large light bulbs. Look at the size of the light bulb socket there. Oh my gosh, and he's got no lights. Of course, those are odd. Okay, still nothing. Get it up around 60 volts. And typically you need about 90 volts to make one. 60, 70, let's try 80 volts. Maybe there's some kind of electrical breakdown that's going to happen at some point, and we're going to go from no action to smoke instantly. Nothing whatsoever happening. Okay, this guy's still not reading. He's still below 100 here. We're really getting into the range of full voltage here. Are these tubes heating up? Is anything happening? Is there anything happening? I don't think so. I don't think anything's happening. We need this guy to tell us how many watts are being drawn by the radio. So I'm going to crank this up a little bit higher. Pick it up 95 volts. Nothing happening. Now, this thing's locked up, so I'm going to interrupt the power momentarily, and when I close it back in, this will probably operate properly. So we have 85 volts, 15 watts. Okay, so it's taking some power somewhere, not in that coil. Okay, so something's happening here. We could have a shorted transformer. That could be what's doing all the power consumption, but I doubt that. I can hear something. I can hear the filaments rattling in the tubes, or what sounds like filaments rattling. A typical sound from things warming up. Now, at some point, the cathodes in the tubes will get hot enough, the B plus will be high enough, there'll be a current flow through the tubes. That'll be a new current flow. Maybe that's the current flow that burns the coil out. So we still have to be cautious here. And of course the coil could be burned open. It could be open circuited. So it's never going to burn again. It's doing nothing. I mean, there's a really high likelihood of that. And I took that reading and read its resistance. We don't really know what I was reading there for sure. Well, let me get my mirror and take a good look at those tubes. Let's see. Look down on them. Oh, there's one with one's got a hot heater. One is heating up. Some of these tubes you can't see in them. Neither rectifier tube appears to be heating up. The rectifier tubes are part of the generation of high voltage. And without any high voltage. Oh, wait a minute. No, one of them's heating up for sure. Okay, we should be in business here. Okay, coil's still not heated. So I think that's a non-issue at this point. It's not going to get hot. It's not hot now. It's not going to get hot unless I throw the band switch. The band switch could be doing it. Hey, is some other coil getting hot right now? There's nothing getting warm in here. Nothing at all. Nothing's getting warm. Okay, we're going to turn the volume up, up, up. Which is the volume? You know, this might be tone. This might be volume here. Oh my gosh. Let me peek at the cabinet for a second. Anybody know where the cabinet is? Where's the cabinet? Okay, I got the cabinet. Oh my god. Oh, I'm pretty stupid. Okay. Well, I didn't have to admit that. I could have claimed I was really smart. And I started this up without the speaker plugged in. Yeah, so I don't have the speaker plugged in. For crying out loud, it's in the cabinet. Somehow I thought it was bolted on the chassis, but I guess I'm getting confused. Okay, so not much of this radio is functioning right now. There should be no B plus in the radio because the high voltage cannot develop without the speaker plugged in, and we're certainly not going to hear anything. Okay, we got to repeat this with the speaker plugged in. That was it. Now, it can make sense to start a radio up with this sort with the speaker unplugged. You've got a field coil speaker, specifically because very little of the radio is being energized, and that's a good testing opportunity. Did I say something about keeping yourself safe? Oh my gosh. Just gotta jump through the roof there. Okay, gotta run and do something. Okay, let's get ready for attempt number 2. Now the on-off switch is on the tone control. Is quite a common thing in these old radios. That makes this the volume control. And I certainly had trouble. Perfect. Certainly had trouble turning it. Let's see. Ugh. Yeah, it needs a little lubrication, probably just on the shaft here. And bit of WD-40 right on the shaft. A little bit. Wow, that's really, really tight. So it's not the best sign. It might suggest there's something going on inside the volume control, but I won't worry about it just now. We'll turn it down, turn it up about a quarter turn. Very good. The antenna is free and clear over here. This time I have the speaker plugged in. We are still aimed at the coil on here. Radio's plugged in. This time's for real. This is for real. We're back down to almost started nothing. Here we go. Okay, plus I'm maintaining these dim light bulbs in the circuit. Once again, because I'm a chicken. And we are. Okay, of course nothing's happening at all. We'll take it up to, let's say, 30 volts. I can't expect much to happen yet. But once again, because I don't know what's going on, I'm going to be very cautious with this. Oh, this is actually working. 36 volts. 4 watts. Let's go up. 60 volts. 8 watts. A radio like this would normally run 40, 50, 60 watts. Something in that range. That's where we're heading. What do we see happening here? We see nothing. Nothing happening yet. Now, so we're at maybe enough to see a heater. Don't see any yet. Okay, we're going to go up a little higher. And most radios will kind of work at 90 volts. Oh, I can hear it. What's happening? Things are happening in the radio. Unfortunately, my house air conditioner just came on too. So we have the additional rumble from that. No heat here. The radio sounds like it's working. We don't know what band it's on. For all I know, I flip that band switch and the situation with this coil changes entirely. I may have it on the other band. There's no heat developing though. How could you tell what band it's on? If we could pick up a station. No antenna. Let's get the voltmeter out here. Poke around. Now, how can I possibly tell if there's any voltage on the chassis here? It's a very, very high impedance meter. It may respond to me just holding one lead and touching the other. That's the DC. That was DC. AC, more than 6 volts, 600 volts. So 13 volts. So that's fine. That voltage would get there, I would have to guess, through capacitive interaction. Just leave it at that. Yes, it's the capacitive interaction happening. The windings in the power transformer act like a lousy capacitor against the shell of the transformer, and that can get something going onto the chassis, and then my highly sensitive meter can read a number. But if I took a regular meter, I'd probably see nothing at all. Oh, I wanted to check the antenna. I wanted to check the antenna voltage. Shouldn't be anything there, of course. Let's check that. And even the other wire that's sticking out the back here. So, voltage to chassis. There's nothing there. And this other wire. Nothing there. do one more chassis test here. Although because the radio is isolated from the hydro system, I shouldn't really get any kind of response here that makes any sense. Let's see what we see. 21 volts. Still reassures me. If I saw 120, wouldn't be quite so reassured. If I saw 60 there, that would tell me a little something. That's half of 120. In case your mathematics isn't so good, there's no heat here at all. The radio's operating, no heat. We don't know what band we're on. You know what? It does show on the cabinet the band. It's just so I saw a picture of this radio, and it showed a knob on the band switch with a pointer pointing downwards. The words are down below. The knob that's on here, you know what I think has happened? The knob that's on this control is the wrong knob. This knob, when the radio came here, should have been up on here. And the knob that's here is kind of a pointed one, and you're flipping it from band to band. Okay, so that being the case, and I can look again. So short wave would be with the switch rotated clockwise. Let's cut the power and see which way the switch will rotate. I'd really rather have a knob on it, but I'm too lazy for that right now. Grab the tool. Think again, which way do I get this wrong? So if it's rotated clockwise, it's on shortwave. Okay, so it was rotated clockwise. So now we've rotated it onto broadcast. So now that coil maybe now is in the circuit and wasn't before. I don't remember exactly what I saw on the schematic, so we're going to start over. Go down, because we think this is the first time we're actually energizing the coil of question. Okay, power on. Raise it up to 30. And watch. Watch for any heating. The fact that some sound came out of the speaker is very good. That's a good thing. Okay. Pick it up to around 60. 54 volts. See, I have the dim bulbs in the circuit, so there's some voltage dropping on those light bulbs. So it may send 60, but only 54 is getting here. The other 5 are on these bulbs. No heating effect. Let's go up higher. Okay, we're up around 90 now. This is the radio should work. Well, 80. Radio may work. No sign of heating whatsoever. Oh, what was that? What was that? What did I just see? Did I see some weird? Did I see a reflection in my room here? I saw some weird thing. I don't know what that was. Last little blast of hot air coming out of that coil. You can actually see hot and cold air with this thing. If you set the limits, there's limit settings on this. You can control, at what temperature the screen turns red and stuff like that. So if you set it just right, you can actually watch cold air pouring out of, say, near one of your windows, pouring out and bubbling down towards the floor. This is really cool. This is a really cool thing. Maybe not like this particular one. Any one of these things is extremely valuable. There it goes again. You know what it is? I don't know if you can see this on camera, but if you tip your head up far enough, you can start seeing funny little things happening up in the top corner there. See them? But when you're down here, you don't see them. Okay, don't go looking for trouble. That's exactly what I'm doing. I'm looking for trouble. Okay, we'll take it up now to pretty much normal. Well, we'll get it up in the certain to operate range here. Hear the radio? Getting louder. 90 volts. Let's hold it here. Volume control check. Okay, not making any difference with this noise. The noise is probably a power supply problem. But no heating going on in this coil at all. Any reception from this radio. Well, my hand's affecting it. I couldn't exactly call that reception. Okay, so I'm going to touch the top. A lot of these tubes, let me just hold this briefly. A lot of these tubes have grid caps on them. Okay, we can tap those. There's only the odd tube that has a plate cap. Yikes. Okay, this might be loud. Not much happening there. So that is the, I believe that's the 6Q7. So that's the detector tube. And what that shows is things are working past the detector tube. But ahead of that, I'm touching the grids and nothing much is happening. We're missing the batteries that were in here. It might be better to have the dead batteries in here than to not have them in here. Okay, so we don't know what to do about this coil. Is there anything else getting hot in here? Hot things would be quite red on the screen, not green. You're seeing things like socket bases. Okay, there's something right up in here. That's quite hot. Very hard to see on the screen here and know what you're looking at. This is a very wide angle camera. It's very, very wide angle. So it's very tricky. So put it in the middle, read the temperature, 32. See, it's not even hot. Whatever it is, 30, 30, that's nothing to worry about. Okay, tone control, what does it do? So again, that's the audio side of the radio functioning. And tuning. Oh, heavens, what happened there? Oh yeah, that's right, this is the clunkiest tuning thing going. We've got to sort that out. It's just terrible. No change in the radio. Okay, let's shut it down here. So we have a little bit of good news, I think. There's a good chance that the coil here is intact and actually functioning, oddly enough. I've glued it so it's stabilized. If we're lucky that's the situation, then I don't do any more with it. We'll just leave it as it is, if we're lucky. We discovered sound comes out the speaker. That proves the audio parts of the radio would be operating. And didn't really get any effect when I injected signal into the antenna. So probably the next step in this affair is to test the tubes in this particular radio. When I approach these radio repairs, they're all a little different. In the end, you travel down a road doing different things. When you get to the destination, you will have done all the things. It's the order in which you do them as you travel down the road that changes. But in the end, you pretty much do everything. So, but I think on this radio, tube testing will be the next thing. Let's see how hot this transformer got. Okay, don't feel any heat in the transformer. Trying not to strain the speaker wires here too much. Yeah, didn't do a good job on that. Yeah, see, this wants to sit like this, and the wire wants to go there. That's a dumb thing to do there. Okay, I'm just going to have to put it back and not worry about it. really do much. Okay, nothing I can do about it. That's a little better, actually. I have got it. Okay, yeah, tube testing next, and we'll see where we go from there. Great. Well, thanks a lot for watching, and I'm out to enjoy my day. It's a beautiful, beautiful day here today. I should be outside. See ya.